The environmental video series 2000 is intended to provide the youth of Nunavut a brief introduction to some of the major environmental issues in the north.
Hi, I'm Baba.
And I'm Pam. In our segment, we will be presenting bioaccumulation and biomagnification.
In our segment of this environmental video series, we will be explaining some basic ecological concepts, such as how organisms and ecosystems are interrelated, and how energy and biomass pass from one organism to another.
We will use the concepts as a starting point to help us explain bioaccumulation and biological magnification, and show how these processes can negatively affect human health.
Hi, I'm Selena.
And I'm Mark.
In our segment, we will be talking about climate change.
We will focus on the issues of ozone depletion and global warming.
On the topic of ozone depletion, we will look at the ozone layer, the ozone molecule, causes of ozone depletion, where it happens most, and much more.
For global warming, we will be explaining the natural greenhouse effect, enhanced greenhouse effects on global warming, and how global warming affects the north.
Hi, I'm Jeff. In our segment of the video, we will be introducing sustainable development. For our segment on sustainable development, we will talk about wildlife management and how it works in Nunavut, and the importance of co-management. We will see how environmental enforcement works in the north and who enforces the regulations. We will also find out how important traditional knowledge is to establish a workable system of wildlife management in Nunavut.
Entering the 21st century, our world, our environment is changing. Because of human activity, the rate of change is greater than ever before.
The atmosphere, our protective blanket, is weakening by greenhouse gases and gases that deplete the ozone.
The oceans are polluted by raw sewage, oil spills, and radioactive wastes.
Water, disrupted cycles, drought in Africa, floods in the Red River, Manitoba, land, deforestation, desertification, our earth blown away into dust.
Our video will focus on ozone depletion and global warming in the Arctic.
Resolute Bay is located on Cornwallis Island. It is the second most northern community within Canada. Population about 210 people.
Residents of and visitors to Resolute Bay realize that the location of this town is unique and different. It is 74 degrees north and 94 degrees west. That is 700 kilometers from the magnetic North Pole and 1,700 kilometers from the geographic pole. We are 1,561 kilometers northeast of Yellowknife and 3,444 air kilometers northwest of Montreal. 5,872 kilometers from Paris. 10,129 kilometers from Moscow. Resolute Bay.
Resolute Bay is the location of one of the few climate and ozone research centers in Canada.
Weather in Resolute has changed from being a very cold and windy place to a not so cold and windy place. That's also, everything has changed with respect to wind direction. The winds used to be dominant from the northwest. Now they are dominant from the east, southeast. So things have changed a great deal. As far as the winters are concerned, lately they've been quite warmer than they used to be as well. And lot more snow, too.
Relatively speaking, the Earth's surface is about as thin as a skin of an apple. About 99% of the Earth's atmosphere occurs within 50 kilometers above the Earth's surface. The remaining 1% extends outward for several hundred kilometers, fading gradually into interplanetary space.
Every day, the ozone is getting thinner and there are more UV rays hitting the Earth. In this segment, we will be talking about the ozone molecule, the ozone layer, and ozone depletion. Causes of ozone depletion and where it is most depleting. Also the effects of UV radiation, why it is important for people to know about it, particularly the people from the north.
The sun shines 24 hours a day from April to August here in Resolute. Got to protect the skin and eyes in Resolute.
What is ozone? The ozone molecule is made up of 3 oxygen atoms.
Ozone can be found anywhere in the atmosphere, but the layer with the most concentration of ozone is located approximately 15 to 35 kilometers above the Earth's surface in the stratosphere.
My name is Warwick Vincent. I'm a professor at Laval University. Well, ozone is a form of oxygen. It's a molecular form of oxygen composed of 3 atoms of the element oxygen. And in particular, its characteristic is that it absorbs very strongly in the ultraviolet part of solar radiation. So the ozone layer, which is up in the higher atmosphere and the stratosphere, acts as a natural shield around the planet. The ozone is primarily in the upper atmosphere. It's many kilometers, the top of the atmosphere, in a relatively thin layer, in high concentration. And it's
Okay, daily we record, we do 2 balloon flights. That's the most noticeable thing. And a PUR. And these balloons help measure the temperature of the air all the way to the stratosphere. Then we measure how much solar radiation hits the ground. We also measure how much ozone there is by measuring how much ultraviolet radiation hits the ground.
The ozone layer is important because it absorbs UV radiation, therefore protecting us.
But how does the ozone work?
The UV rays break up the ozone molecule, making an oxygen molecule and an individual oxygen atom. The oxygen molecule and the free oxygen atom quickly reunite, releasing heat in the process. This is how the ozone layer absorbs UV rays.
Did you know ozone may be formed not only by the action of UV radiation, but also by the action of a high voltage electric discharge? Therefore, very small amounts are also formed during thunderstorms.
Ozone depletion occurs when destruction is greater than production. The polar regions are vulnerable because of the unique condition they are in. These areas are subject to a cold, dark season where there is no sunlight. The ozone-depleting chemicals arrive here from other places. The pollution gets here through the transportation of the Earth's atmosphere.
Depletion of ozone is associated with pollutants that are produced by human activities throughout the world. In particular, CFCs, chlorofluorocarbons, that have been used in the past for a variety of industrial applications, that have been used in refrigeration systems, for example, from about the 1940s onwards. These compounds have been released and they've gradually made their way up into the atmosphere. It turns out that in the polar regions, there are the production up in the stratosphere of clouds of ice crystals. And the CFCs end up on top of these clouds, right next to these crystals, and interact at that point, react with the ozone in the stratosphere, and in turn break down the ozone, which in turn results in the ozone holes that we see today, and the increase in UV radiation as a result of that.
Can you tell us where the pollutants are coming from?
Well, primarily they're associated with industrial activities in the northern hemisphere. And in fact, that's kind of bizarre because the first indication of this problem in the stratosphere occurred in the southern hemisphere, is in the South Polar region, about as far away as you could possibly get from the major centers of human activity. But it became clear that in fact this was the result of primarily activities in the northern hemisphere, and then through global circulation processes, these pollutants were redistributed throughout the planet. And because of the extreme cold in Antarctica and the production of ice crystals there, that was the region where we started to see the problems first.
Did you know UV radiation increases with altitude and up to 85% of UV is reflected from fresh snow? Skiers, mountain climbers, and Nunavut beware.
The effects of UV radiation exposure can vary from skin cancer to premature aging and to cataracts or other eye damage. So wear your skin lotion and sunglasses to protect yourself.
Wildlife in the Arctic is particularly vulnerable to UV radiation. The sun in the Arctic never rises very high above the horizon, which means UV levels are low. However, with the depletion of ozone, these levels will rise, causing problems with plant life and animals that are sensitive to UV. Climate change is not new. Temperature, one element of climate, varies within years, decades, centuries, and even thousands of years.
With all of this variation, how is it possible to tell if these changes are natural or caused by humans?
Did you know global warming is a term made popular by media and the scientific community to mean any change in climate that result from higher global temperatures?
In this segment, we will be talking about the natural greenhouse effect, enhanced greenhouse effect, effects of global warming, and how it affects the North.
What is the greenhouse effect?
The greenhouse effect is the popular term for one of the functions the atmosphere plays in the global ecosystem. Each day, the Earth is bathed by sunlight. Solar energy penetrates the Earth's atmosphere. Some of this energy is reflected back into space. The rest of it is absorbed by the Earth's surface and re-emitted as infrared radiation. Some infrared radiation reflected from the Earth's surface immediately escapes into space. Most of this radiation is absorbed by water vapor and other greenhouse gases, warming the Earth's surface and the lower atmosphere.
All energy received by the Earth from the sun returns to outer space eventually. Therefore, the Earth neither gains nor loses energy, and neither cools nor heats up.
Without the greenhouse effect, the Earth would be 33 degrees colder. Organisms would die, we would die.
So what's the problem? The problem is that human activity increases greenhouse gas concentrations. This enhanced greenhouse effect can cause an unnatural increase in global temperatures.
The general warming is to do with natural changes, but exacerbated or added to by global warming, as it's called, due to carbon dioxide largely that humans have been putting into the atmosphere through burning stuff. And that's been increasing the amount of energy that the Earth retains from the sun, because it's like a greenhouse, as it's called.
Greenhouse gases include water vapor, which comes from natural respiration, transpiration, and evaporation. These increase as the Earth's surface temperature rises.
Carbon dioxide is produced from burning materials and fuels. Its volume in the atmosphere is the second highest of all greenhouse gases.
There is less methane in the atmosphere than carbon dioxide, but it's a more effective greenhouse gas. Its primary sources are wetlands, rice paddies, animal digestive processes, fossil fuel extraction, and decaying garbage.
Halocarbons were invented only 100 years ago. Chlorofluorocarbons, or CFCs, are the most familiar of these chemicals. Nitrous oxide and ozone also contribute to the greenhouse effect.
As human population increases, so have our use of the planet's natural resources. Burning fossil fuels and clearing of forests for farms and buildings contribute to the increase of carbon dioxide and methane. Only 1% of gases in the atmosphere is responsible for the greenhouse effect. Therefore, even small changes in the greenhouse gas concentrations can be significant.
Is it getting warmer?
We think it indicates a warming trend. And that warming trend has been called by some people global warming.
On average, our temperatures are sometimes 4 or 5 degrees warmer each month.
The globe is warming up, the Earth is warming up.
Over the past 100 years, the Earth has warmed an average of 0.5 degrees Celsius. This change may be explained by natural temperature variation.
But at this point in our history, the important things are how fast the changes are expected to happen. 7 of the 10 warmest years occurred in the 90s.
What are the effects of global warming?
To us Canadians, in the middle of freezing cold February winter, the thought of warmer temperatures may not sound so bad.
But even a small change in global average temperature can have drastic implications.
The effect of a rise in average global temperature can only be estimated based on scientific data.
My name's Julian Dowdeswell and I'm from England. I'm a glaciologist. If warming does take place, glaciers and ice caps are likely to melt.
It is predicted that extreme weather, floods, droughts, forest fires, water shortages, and melting of the ice caps will increase.
What effects will climate change have in the Arctic?
Higher temperatures in the Arctic could lengthen the summer season, melt permafrost, and reduce the extent and thickness of floating sea ice, resulting in a rise in sea level.
Many people are starting to believe that the global warming is having an impact on how long the summer season is and how long streams run during the summer, how much the glaciers are melting.
The Arctic ecosystem is very fragile because the plants and animals have become highly adapted to live in this extreme climate and environment.
A warmer climate with milder winters and less sea ice would mean less access to offshore food resources.
Seals are the main food source for polar bears. Their main strategy for hunting seal is from the sea ice.
Walrus and bearded seals require sea ice strong enough to support their weight, so over shallow water they can reach the bottom to feed.
Ice will form on top of snow if there is a warm snap during cold periods. Caribou and muskoxen are greatly dependent on tundra vegetation, such as lichen, for food.
A shorter winter with increased snowfall may decrease the ability of people to hunt and trap.
The melting of the permafrost that underlies the Arctic due to global warming would cause buildings, roads, pipelines, and any other structures built directly on the land to become unstable.
tens of thousands of northern Canadians would be affected.
In our segment, we have talked about the ozone molecule, the ozone layer, and ozone depletion, causes of ozone depletion, and where it happens most.
We also spoke about global warming, including natural greenhouse effect, enhanced greenhouse effect, and effects of global warming.
Nunavut kajanang ingatakun ng walatu. Ukit sanulito kajanalong wakan ibang niyo. Nunavut ako silip tumikat janapan. Ukil muli domingan. Uvian alon wakan ibang niyo. Naliw ng siyo na akagulo dahil takon mo. Upil manuliw sila kamay nakatapin namutoy na ingat kalunit kaya mo sumapto ayan ulit amin man uven along wakan ibang milyon umiat ingat kaluni namutoy na kuvean akto si jakut pisutuman isu masak siu kadakaman Nunavut kajanang ingatakun ng walatu. Tuki siti tawungan at suron na tukakane Oko may sanak tukakane Inusuma manali piuna samarane Si jakut bisutama Isu masak siyo kadakama Nunavut ka dyan ang mga kakunang wala tulo Nunavut ka dyan ang mga kakunang wala tulo
The environmental video series 2000 is intended to provide the youth of Nunavut a brief introduction to some of the major environmental issues in the north.
Hi, I'm Baba.
And I'm Pam. In our segment, we will be presenting bioaccumulation and biomagnification.
In our segment of this environmental video series, we will be explaining some basic ecological concepts, such as how organisms in ecosystems are interrelated, and how energy and biomass pass from one organism to another.
We will use the concepts as a starting point to help us explain bioaccumulation and biological magnification, and show how these processes can negatively affect human health.
Hi, I'm Selena.
And I'm Mark.
In our segment, we will be talking about climate change.
We will focus on the issues of ozone depletion and global warming.
On the topic of ozone depletion, we will look at the ozone layer, the ozone molecule, causes of ozone depletion, where it happens most, and much more.
For global warming, we will be explaining the natural greenhouse effect, enhanced greenhouse effect, effects on global warming, and how global warming affects the north.
Hi, I'm Jeff. In our segment of the video, we will be introducing sustainable development. For our segment on sustainable development, we will talk about wildlife management and how it works in Nunavut, and the importance of co-management. We will see how environmental enforcement works in the north and who enforces the regulations. We will also find out how important traditional knowledge is to establish a workable system of wildlife management in Nunavut.
We live in a world that is producing a lot of different chemicals, which are both dangerous and helpful to humans. These chemicals have been dumped into our environment for years. We are beginning to find these chemicals present in our food sources as well as our environment. What can these chemicals do to us and the youth of our communities? And how do they get into our food? These are two of the many questions we will be trying to answer in our video. Welcome to the first part of our environmental videos, and welcome to an introduction to bioaccumulation and biologic magnification.
Ecology is a branch of science which deals with how organisms relate to their non-living environment and to other organisms. The aspects of ecology we are primarily concerned in are food chains and food webs. A food chain is a group of organisms which are connected by energy and biomass.
Here is an example of an aquatic food chain. This food chain begins with the sun. Some of the sun's energy is trapped by the phytoplankton. Phytoplankton is like a very small plant. It uses the process of photosynthesis to harness the energy of the sun to create glucose molecules from the water and carbon dioxide. Some of this trapped energy and biomass is transferred to the zooplankton when they consume the phytoplankton. Small fish eat the zooplankton and receive some of the energy. Large fish eat the smaller fish, and then some of the energy is transferred to them. At the top of the food chain, the fish-eating bird or large predators receives some of the remaining energy and biomass. So the sun's energy has been used either directly or indirectly to keep everything alive. A food web is a group of interconnected food chains. This is closer to reality. A certain plant or group plankton is not consumed by one species of animals. It is consumed by many. In this picture, it is easy to see how buds, twigs, barks, and leaves are a food source of lemmings, deers, and mouse. It is important to remember that when a wolf or a consumer eats another organism, it gets energy, also gets material such as proteins and fats to build its own body with. This material is called biomass. It is necessary to know these ecological concepts to be able to understand bioaccumulation and biological magnification. In the terrestrial food chain, the number of steps or trophic levels are fewer. An example might be likened to caribou, to human. In this situation, contaminants have less opportunity to be magnified. In the marine food chain, there are potentially many more trophic levels in that food chain. At each trophic level, the concentration increases. The plankton absorbs the contaminants from the surrounding water. Plankton in turn is eaten by fish. These fish are later consumed by seal, which are eaten by polar bear. When we finally eat the polar bear meat, we are eating an animal which occupies the fourth trophic level.
Well, my name is Ben Wheeler. I'm a biologist, a marine biologist by training. I have a master's degree in marine biology.
Can you explain how food chains and food webs work, and how do they tie in with bioaccumulation and biomagnification?
Well, that's not a very easy question to ask because it's pretty complex. Food webs are really complex things, sort of interwoven nests of things. Well, the basic way of explaining it is that one thing eats another, and that eats another, and that eats another into this sort of huge system. In the Arctic, the way it works, at least in the marine environment, is that you have this small little plankton that's in the sea, and it converts the energy from the sun into something that any other animal can use. And then something a little bit bigger comes along and eats that. That'd be called a zooplankton. And then something bigger than the zooplankton will eat the zooplankton, and then it keeps going up and up and up like that.
Contaminants are substances that are found where they should not be. We are primarily concerned with harmful substances like organochlorines, metals, and radionuclides. Organochlorines are manufactured chemicals. Some examples of organochlorines are DDT, PCBs, and toxaphene. Metals are elements that occur naturally if its concentrations in living organisms get too high. The effects can become toxic. Examples of these are mercury, cadmium, and lead. Radionuclides are radioactive matters that can easily contaminate a wide area.
Well, the big problem in the Arctic here is that you have a lot of these POPs, like you talked about before, that have been sort of blown up from the south. And right now it's mostly on the ice. So as soon as the ice melts, it's going to go into the water. The things that are really in contact with that are the little zooplankton and the little phytoplankton. And just through sort of simple chemical processes, the chemicals, the pollutants, get absorbed into the plankton. So then when the bigger, plankton eats the smaller plankton, and then a fish eats the plankton, and then a seal eats the fish, and a polar bear eats the seal, then it all gets sort of progressively there. But it starts right with the plankton.
When animals eat persistent organic pesticides, the contaminant will usually be found in the fat or in the organs, like the liver or kidneys. If contaminant levels get too high, the effects can include problems with the developing of young reproduction, resistance to disease, some types of cancer, and mutation.
The water contains contaminants which are absorbed by tiny plankton, which are eaten by shrimp and other crustaceans. These crustaceans are then eaten by Arctic cod and other fish. The fish are then eaten by beluga whales. Every time it moves up the food chain, it is magnified.
Marine wildlife is part of a longer food chain, so there is more biomagnification. In the Arctic, there are a lot of fatty animals with long lives. These animals are very good indicators of the presence for contaminants. Freshwater fish haven't had any levels of contaminants that are high enough to cause a cancer or threaten human health. Land animals having heavy metals and radionuclides. Land animals such as caribou aren't as affected by biomagnification because of their food chains are short. However, they are finding cadmium in the kidneys. The concentration of cadmium in the body of land animals increase over time. Radionuclides are no longer a concern because atmospheric nuclear weapons testing has stopped.
As shown in the picture, the primary consumer in this diagram, which is the zooplankton, is 3,000 times more concentrated with contaminants than the surrounding ocean. Small fish are 160,000 times more concentrated with contaminants than the ocean. Large fish have 700,000 times more contaminants than the surrounding ocean. Fish-eating birds are 8.5 million times more contaminated than the surrounding ocean. Where do contaminants come from? Most of the contaminants we are concerned with have never been used in the north, and many of them have never even been used in Canada or are banned. This shows that different countries are major sources for many contaminants that are found in the north.
It has been found that contaminants reaching the Arctic are mainly carried in the atmosphere as gas or particles, dust in the wind and clouds. The atmosphere is the fastest way for substances to move around the world.
Can you introduce your occupation?
Yes, I am an environmental technologist or environmental technician. I do multiple disciplines, multiple functions with respect to monitoring the atmosphere and also other things related to the environment in a physical way, in physics way.
During your time in the north, have you seen some changes in the weather patterns?
The north is definitely getting warmer, right? The winds are not, the dominant winds are not the same. That's the two basic ones that I've noticed the most around here. The spring is warmer here, much warmer than it used to be as well.
With your many years as a weatherman, do you think that contaminants travel to the north by the atmosphere?
It depends on which way the company, the industry, or the governments dispose of their waste. Some of them burn their waste. They just literally burn it at high temperatures. The stuff goes into the atmosphere away from their country. Eventually, it comes to us most of the time through the winter. And in the springtime, you perhaps noticed it, that there's haze around, right? A few years ago especially, that was the case where there was no clouds and the sky was like grayish, like in a city, if you've been in a city before down south. That's after all this pollutants came back or went to the north. And eventually when the sun rises, there's a chemical reaction, a photochemical reaction that occurs with the chemicals, and it turns the sky milky white. Yes, there is a lot of that stuff coming up here.
It may take only a few days for something released in continental Europe to reach the Arctic. The contaminants can also travel through the ocean currents. Snowmobiles, cars, furnaces, and other fossil fuel burning machines release pollutants into the northern environment. We should look up ways to reduce local emissions into our environment. It's not noticeable if the food has high levels of organochlorine metals or radionuclides. Contaminated food might taste exactly the same as uncontaminated foods. Northern traditional foods are more nutritious than store-bought southern foods. Food preparation techniques can lower the contaminant contents. Boiling meat or fish can reduce the fat content of food because organochlorines are stored in fat. Less fat means less contaminants can be passed on.
Hi, Uta.
Hi.
How long have you been eating traditional food?
Since 1945.
Have you noticed any different tastes?
Like how?
Like freshness and
Oh, yeah.
contaminated.
Huh?
Freshness and contaminated for you.
No, I couldn't tell. No. I like traditional foods. And then they all have a different taste. So I don't really know. I wouldn't know even if it was contaminated.
People may be exposed to contaminants through a variety of sources, such as food, water, air, soils, or consumed products. The food are the main source. Your occupation can put you at risk too. People doing mining and smelting operations, workers in chemical plants, and farmers using pesticides can come in contact with contaminants. People in the north live off the land and ocean. They can have a healthier diet than people that don't. Traditional foods are more nutritious than other foods that are bought from the store. Children who are raised to eat traditional food will have a better chance to grow big, stronger, and healthy. Adults who eat a lot of traditional foods, especially fish, are protected from having heart attacks. Personal habits like smoking, alcohol, or even drugs can increase you to have a heart attack or stroke and cancer. Also, it can increase risk of poor health for children and newborn babies. Cigarettes have much more cadmium than caribou, and this should be remembered.
This problem is being guided by regional consultant working groups. To find out more about levels of contaminants in people, they may ask to sample your hair and blood. Long-term effects of country food contamination in people are not yet known. Some researchers believe that young children and babies are more susceptible. One thing is for sure, country food has a higher nutritional value than store-bought food.
Country food is an important part of Inuit culture. Anything which threatens our country food threatens our northern culture.
We hope you enjoyed our segment on bioaccumulation and biological magnification. You have learned a little bit about ecology and how all organisms are interrelated. You have heard researchers and field workers explain how contaminants are carried into the Arctic and how they work their way into our food.
If you have more questions about bioaccumulation and biological magnification, contact your local Hunters and Trappers organization or the Department of Sustainable Development. Bye for now.
Ciao.
Thank you.
The environmental video series 2000 is intended to provide the youth of Nunavut a brief introduction to some of the major environmental issues in the north.
Hi, I'm Baba.
And I'm Pam. In our segment, we will be presenting bioaccumulation and biomagnification.
In our segment of this environmental video series, we will be explaining some basic ecological concepts, such as how organisms in ecosystems are interrelated, and how energy and biomass pass from one organism to another.
We will use the concepts as a starting point to help us explain bioaccumulation and biological magnification, and show how these processes can negatively affect human health.
Hi, I'm Selena.
And I'm Mark.
In our segment, we will be talking about climate change.
We will focus on the issues of ozone depletion and global warming.
On the topic of ozone depletion, we will look at the ozone layer, the ozone molecule, causes of ozone depletion, where it happens most, and much more.
For global warming, we will be explaining the natural greenhouse effect, enhanced greenhouse effect, effects on global warming, and how global warming affects the north.
Hi, I'm Jeff. In our segment of the video, we will be introducing sustainable development. For our segment on sustainable development, we will talk about wildlife management and how it works in Nunavut, and the importance of co-management. We will see how environmental enforcement works in the north and who enforces the regulations. We will also find out how important traditional knowledge is to establish a workable system of wildlife management in Nunavut. Nunavut, what do you think of when we hear this word? polar bear, caribou, whales, clean air and water, pristine landscape. Our most valuable resource seems to be the land and the animals that inhabit it. How can we ensure that we will always enjoy such precious resources? With a growing population, there is an ever-increasing demand on wildlife and other resources. In order to preserve for the future, we must manage for today. Sustainable development is a phrase that describes how our government and other organizations ensure that future generations will enjoy the same resources we use today. Through wildlife management, we can ensure that we do not overharvest our wildlife resources. Polar bears are intensively managed in Nunavut by the government. Tagging and monitoring of bears is an ongoing process throughout the north, so that the latest population estimates are available to set quotas. Other animals such as caribou are also managed in Nunavut. Biologists collect information on reproduction, migration, food availability, and survey the land base to understand how to best utilize the animals.
Government biologists work with Inuit organizations, including consultations and cooperations with local hunters and trappers associations. When research is proposed or management decisions are being made, it is a requirement of Nunavut government to incorporate traditional Inuit knowledge collected from local hunters and elders into management decisions. When animals are harvested, information on the number of animals taken, their sex, age, and where they were killed is recorded by local wildlife officials. This information is used to determine the effect hunting has on local wildlife populations. If it is apparent that a decline in animals in an area is related to an overharvest from hunting, biologists can recommend the quotas be reduced or hunting be limited in that area. Wildlife officials have the ability to prosecute individuals who violate Nunavut and Canadian acts and regulations that pertain to wildlife and the environment. Charges can range from hunting without a license to discharging a contaminant into the environment to exploiting and importing an endangered species.
This video will introduce some of the responsibilities our government and other organizations in Nunavut have to provide you with clean air and water to provide and maintain our hunting and fishing opportunities, and to keep our land and animals healthy.
We will discuss wildlife management and co-management, environmental protection and enforcement, and traditional knowledge in depth with experts in each of these areas. Let's dive right into our first topic, wildlife management and co-management. What the heck is wildlife management?
Okay, you're booked in Caesar Palace in June. You'll be fighting Lennox Lewis for the heavyweight title. Let me see your intimidating face. Give me the stare. Let's see the fight in your eyes. You're a contender. You're tough. You're mean. You're the champ. Talk to me. Yeah, I can do that. Get his secretary to call my secretary. We'll do lunch.
Wildlife management, as explained by the Assistant Director of Wildlife for the Government of Nunavut, is the stewardship of wildlife species.
Jacob Gienig, a wildlife officer in Johaven, sees it as a way to protect our current level of
wildlife management is to use the wildlife that we have in the north properly so that we don't overharvest them. We make sure that we have plenty of wildlife for our future, our kids' kids.
What it really boils down to is monitoring critical wildlife population, controlling the human impacts on wildlife population, and enforcing regulations through development of legislation all for the benefit and well-being of people and the animals in Nunavut.
How does this process work in Nunavut?
It really begins when the government or the people see a problem or have a question in regards to wildlife. For example, let's say that the people of Resident Bay notice there are no more prairie caribou around. The government or other organizations may want to step in and figure out why. It takes the expertise of many people to make a management strategy work. The consultation will be held with the people of Resident Bay, with local hunters and trappers groups, regional wildlife agencies, and territorial wildlife organizations. This collaboration among many different groups is called co-management.
Co-management is bringing many groups together to make decisions about wildlife. It's based on consensus and brings the concerns of everyone, including community members, to the table. It's been interesting to see the local HTAs developing their own wildlife research proposals and funding them through the government. This has been made possible only recently through co-management principles laid out in the Nunavut Land Claim Agreement. The Nunavut government and Inuit organizations have really come together to develop this approach to wildlife management.
So I see that co-management is an important step in the management process in order to bring out all the concerns and all the different perspectives towards a particular wildlife issue.
The Nunavut Wildlife Management Board was established under the Nunavut Land Claim Agreement to protect the beneficial use of Nunavut wildlife for the people. Using sound principle of conservation and sustainability, really they are there to work with the government to develop management strategy. There are many other organizations in Nunavut involved in this process.
NWMB, an umbrella organization for QWB, KWB, and KHTA, work with local HTOs, while NTI oversees beneficiary rights pursuant to the NLCA through QIA and the KIAs. NIRB becomes involved for consultation, as well as DIA-ND and other federal agencies such as EC, DFO, and CWS if required. The RWOs and HTOs, along with WOs, can assist DSD to develop MOUs consistent with the NLCA. COS, EWIC, WAPP-RITA, and CIT-IES were developed with NGOs such as WWF to guide governments around the world.
As you can see, the process can be a little confusing. But doesn't it seem that we are doing a great job in Nunavut to include everyone in the management of our wildlife?
Let's talk polar bears. Here in Resolute Bay, we are allowed to harvest 35 bears. Why 35?
Well, biologists looked at the populations of bears around Resolute Bay and using complex mathematical formulas decided that 35 bears was just the right amount of bears to harvest every year without any decline in the population over time.
So these scientists go out and catch polar bears. By comparing the number of bears tagged in an area to the number of those bears recaptured over time, and use these complex mathematical formulas, they can estimate how many bears there are in a population. Let's catch up with the bear tagging crew.
Okay, we got a single set of trucks at 12 o'clock. There it is, over on the rough ice. Good shot, Mitch. 3 minutes and he'll be out. All right, let's get going.
he goes. It's been a good day.
In Nunavut, the federal and territorial government share the responsibility of environmental enforcement. The Department of Indian and Northern Affairs, the Department of Fisheries and Oceans, Environment Canada and Canadian Coast Guard are federal departments that enforce laws relating to the environment. The Nunavut government employs wildlife officers and environmental protection officers to enforce territorial acts and regulations such as the Wildlife Act and the Environmental Protection Act.
Environmental enforcement is the process by which the laws and regulations pertaining to the environment are enforced.
Among their other duties, wildlife officers in your community are trained to deal with many enforcement situations. One of the violations has been identified and evidence collected. An officer has the power to charge and seize items.
To search for items and even arrest is an alternative. An officer can choose to let their local HTO deal with a violation by an Inuit beneficiary.
The new Canada's Endangered Species Act, which protect animals in Nunavut like caribou and bullhead whales, has some serious penalties.
A business can be fined up to $1 million, and a person like you and me could be fined up to $250,000 and spend 5 years in jail if these laws are broken.
Hey, how's it going, man? I'm just about to leave Resolute Bay. I got lots of really cool stuff. We're going to make loads of money.
Excuse me, sir. I'm the wildlife officer here in Resolute Bay. I was wondering if I could have a look through your bags.
Sure, go ahead.
Thank you. Some of the things we do when we're talking about environmental enforcement is enforcing the different acts that we here in Nunavut have, such as the Wildlife Act, the Environmental Protection Act, WAPREDA, the Fisheries Act. Environmental enforcement is taking those laws and making sure that people comply with them.
Do you have many problems with foreigners trying to smuggle animal parts?
What we deal with mostly here is polar bear hides going into the States and marine mammal parts going into the States because they have such strict laws against taking any part of a polar bear or a seal or a whale into the United States. We do deal with that a little bit here.
How do you figure out what animals are being harvested?
I keep track of records for people harvesting animals in my office. Anytime I hear of someone taking a caribou or a whale, I keep all of that in a database on my computer. Some animals are more strictly regulated than others. Polar bear and muskox out of Resolute Bay, I keep very detailed records of the size of the animal, where it was killed, the sex, who harvested it, because they're quoted species and we only have a limited number of tags.
Wildlife officers don't just deal with wildlife offenses. When there's a field spill or contaminant spill, officers will respond and start an investigation and coordinate the cleanup. Samples must be taken in order to provide evidence to the court that a contaminated leak into the environment.
Once samples have been secured, the office will recommend cleanup procedures and ensure that the contaminant is disposed of properly. If it is determined the spill was the result of negligence or unsafe handling procedures, an office can lay charges under the Environmental Protection Act.
Inuit people have lived in northern Canada for thousands of years. Our ancestors developed efficient ways to navigate in harsh conditions, to provide adequate shelter, and to utilize all the land and sea gave them. Living off the land and developing skills to do so used to be a necessity.
Watching and understanding the habits of wildlife, their seasonal migration patterns, their numbers, what they eat, and why they behave in different ways was necessary to survive. The Inuit people had extraordinary knowledge of wildlife because of their independence on it.
Although modern technology and convenience have lessened the dependency on wildlife for survival, many Inuit people retain these traditional skills and knowledge.
Nunavut hunters understand the land and the animals based on first-hand experience. Government scientists have historically relied on numbers and formulas to predict what is happening with wildlife.
In Nunavut, there is a great effort put into bringing these two equally useful systems together to provide successful wildlife management system.
Elders can provide a great picture into the past. Biologists can access information on historical caribou migration routes, what animals used to be where, if disease wiped out local populations, and if there are more animals now than 50 years ago.
It would seem before there were quotas, one man would be able to catch all bears. Now, because of quotas, the bears are protected and won't go extinct for some time. People don't cherish the hides and meat as much now because they have jobs. Before, none of the meat was wasted. It was eaten by the dogs and by the people. The hide was used for clothing or as a blanket. If it was like a long time ago, not having tags, people would catch too many polar bears, especially those with lots of money. I like having quotas because it keeps the bears from going extinct. You are not supposed to waste. Our ancestors didn't waste. Food was made to last all winter for the families and for the dogs.
Traditional knowledge is based on the experience of an individual of a community, as well as knowledge passed down from elders and incorporated in language. This knowledge is consistently being updated as the environment changes and will remain current as long as people still remain close to the land and the sea.
This video has shown you some of the different aspects of sustainable development. We talked about wildlife management and how it works in Nunavut, and the importance of co-management.
We saw how environment enforcement works in the north and who enforces the regulations. We also found out how important traditional knowledge is to establish a workable system of wildlife management in Nunavut.
The principles of sustainable development are similar throughout Canada and the rest of the world. While we are dealing with caribou and polar bears, government in Africa will be dealing with lions and elephants.
In Nunavut, we have developed policies and management systems that reflect on needs and policies of all user groups.
I think we should harvest 5 caribou from this herd.
No, there aren't many caribou here. I think we should only harvest 3. Let's see what the Nunavut Wildlife Management Board has to say.
We agree with that, but let's hear what the elders have to say.
You bet.
Yes.